like him? Sounds like you like him. So Dr. Buch brings 25 years of experience in health and wellness. He has led organizations at some of the world's leading companies and has had success result in more than a dozen patents. This is what I love the most. He is personally responsible for developing healthcare products with annual sales of nearly $3 billion. And his products have been marketed in more than 100 countries. We are so lucky at Young Living to have him and call him our own. And we're blessed to have him here today and speak with us. So please, help me give Dr. Mike Buch a warm welcome.
So this is what I look like when I'm not in farm clothes. I had a great day yesterday with you guys at the farm. Really fun. Got a lot of tough questions, mostly from this guy down here. Had a really good time though, and I love those questions. So now the fun's gonna stop. We're talking about science. No, I'm kidding. I love science, absolutely love science, and I hope by the time we're done with this, you will too. I thought I'd start out by talking about something that I announced at the convention this summer, which is the formation of the D. Gary Young Research Institute. Now, we formed the D. Gary Young Research Institute really with kind of two purposes in mind. The first was to ensure to all of you that we will continue to carry on in the tradition of Gary when it comes to science. We will continue to be innovative. We will continue to question. We will continue to uphold the highest standards as we move forward with our scientific endeavors. That's all Gary's tradition. The other piece of it is that I wanted to remind the scientists who actually work in our laboratories of that same thing, that they are working to uphold the great tradition that Gary set. So we've actually now put the Institute logo on all of the doors going into all of the research labs in the company. And that's just a reminder every day when the scientists come in that what they're doing for you in the tradition of Gary. Now, you will begin to see the Institute logo appear on products as they start to move forward. And I think you'll see the first ones this month, actually. This is just a mock-up label. This isn't a real product. But I wanted to show you what the Institute logo will look like. It's right down here. Okay? So you look for that logo, and then you can be assured that that has the highest scientific standards behind it. Okay? Thanks. And what I actually did when we organized the D. Gary Young Research Institute is we split the R&D team kind of in half. So now there's truly R. So I've got about 25 scientists focused on doing nothing but research. And I've got the other half of the group focused on doing nothing but product development. And that really allows these people to focus their areas of expertise to the best purposes. So I kind of got scolded because I always tend to talk about the research part of this. And the product development team said, no, you got to start talking about what we do because we do a lot of work. And I'm sure you'll agree that there's a lot of products coming out the door, and those folks do a great job. Hey, you can applaud for that. They're great. So I promised to them that I would show you this. This is what the product development process looks like. And the reason it's important for you to see this is so you get a feeling of just how much work is really involved when a new product is developed. We use what we call a stage gate process, so we work in stages. And that way we can ensure that nothing starts before the previous part was thoroughly completed. It's a way of ensuring quality throughout the process. So the first stage, stage one, is actually just where people gather ideas and they present them to myself or to other executives. And we then sign off on it and say, yes, that looks like a viable opportunity that we should progress. It then moves into stage two. And stage two can take a year. Okay, stage two is where we start doing things like what we call the ideation. So if we identify something that people need, we need to ideate on how we'll deliver a product that meets those needs. We also do market research and a lot of other activities in this stage. And as I said before, at this point, it can be a year of work until it actually moves in to the next stage, which is stage 3, to the next phase under stage 2, which is actually the formulation work itself. Okay? This is the stage where we do the laboratory formulation. We see if all of the components in the product are compatible with one another, make sure things don't start to smoke when we mix them and stuff like that. After that work is done, it moves into stage 3. And stage 3 is really kind of the beginning of the phase where we move towards manufacturing a product. The most important part, at least in my mind, of stage 3 is the pilots phase. When we make something called a pilot batch, what we do is we actually go to the manufacturing facility and we make a small batch of product. It's usually about 1/10 the scale size of a full manufacturing run. The reason this is very important is because a lot of times products actually change their attributes when we switch over from the way they were made in the laboratory to the way they're made in a factory, the larger scale. You can imagine there's all sorts of different mixers and different containment vessels and different ways it's pumped and so on and so forth that can actually change a product. So that pilot phase is extremely important for us. That's where we produce the batch that then comes back to the laboratory for thorough testing to make sure that it's still the product that we intended it to be when we invented it in the laboratory. Now there's a lot of other parts that happen in there, and I'm going to talk about one of them in a few minutes, but one of them is called stability testing. And we'll get to that, and that's also a very important part of stage 3. I want you to all realize though, by the time it's at stage 3, this can be 2 years of work, okay? So when people come to me and they say, I have a great idea for a product, and in 3 weeks they call me and say, where's the product? It doesn't work like that. There's a lot of work behind this. Finally, the final stage, stage 4, is where we actually start to move into production. And then the finished products are manufactured, and then it goes into all of the quality testing and all sorts of other testing that can take 6 to 8 months, sometimes even another year. So the entire process to get a product from its idea stage to you, if everything works perfectly, is about 3 years, okay? Now, sometimes we can rush that simply because we're very familiar with some of the types of products that we develop. And we had some luck over the past few years of getting things from idea to market in about 18 months. And I can tell you that's a phenomenal achievement. The company that I came from before joining Young Living is valued at $160 billion. My R&D budget at that company was $8 billion, which if you do the math comes out to about $1 million an hour we spent. Young Living launched 3 times more products than that company when we got here. So that's a real tribute to the dedication and the skills of the folks that we have working in product development.
Because we have you.
Oh, shucks. The other thing that I wanted to mention about this team is that they have started to do a lot of human clinical testing since I got here. We won't test on animals, ever, but we will test on people if they're volunteers and they sign up for it. Sometimes if it's a nasty product, we'll test it on politicians, but that's...
That's great.
But I did want to just remind you of some of the things that we've been doing over the last few years. Since 2017, we've done tests like hypoallergenicity, non-comedogenicidity, phototox, anti-acne efficacy, insect repellency. You can sort of imagine the things because you know the products that we've launched. What I don't know if you know is how these tests are really done. So I thought I'd show you just a few pictures of some of the more interesting ones. So let's talk about SPF testing, sun protection factor. You know we launched the new SPF 50 sunscreen this summer. A lot of work went into that, of course, and a lot of work goes into actually proving what we say. So when we tell you it's SPF 50, we know it's SPF 50 because it's been thoroughly tested. This is actually a photograph of what SPF testing looks like. We get volunteers, actually, you know what, think about this. If you think your job stinks, think of what some of these people do. Okay? We get volunteers who actually volunteer to get sunburned, okay? So what they do is they put themselves under a controlled ultraviolet light, which you see in this photograph. And the sunscreen has been pre-applied to the skin, and then the ultraviolet light is exposed to the skin for a set amount of time. And the timing is such that we actually expose them until they begin to burn. And that's when we cut it off. And that's how sun protection factors are set. So an SPF 50 sun protection factor, for example, means that the person was exposed to this light 50 times longer with this product before they burned than they would have been without a product on their skin. Okay? It's a rough scale. You can stay in the sun roughly 50 times longer. All those things vary a little bit. You tend to sweat it off, you have to reapply it, things like that. And everyone's skin type's a little different. But that's what SPF means. It's roughly how much longer how many times longer you can stay in the sun before you burn. So that's the SPF testing. I want to show you another picture. If you think the SPF testing was bad, take a look at this one. This is testing that we did to test our insect repellent. And here we pay some poor soul money to stick their arm in a box that's filled with mosquitoes. Yeah. And they put their arm in there for a set amount of time. I think it's 2 minutes. And then they remove it and they see how many counts, or they count how many bites were on their arm. And then of course they use it with the repellent and they see how many fewer bites they got on their arm. You can only do the test twice because they only have 2 arms. But seriously, I mean, this is the kind of work that we test on human beings, kind of stuff that we do every day for you to ensure that what we claim is true, because our claims are everything to us. Now, speaking of claims, one of the things that I've always thought is, the old adage, a picture's worth 1,000 words. So I like to do a lot of imaging studies. So the scientists at the Institute are now really gearing up to do a lot of imaging studies where we can generate photos that show our products working. And these photos we can get out to you so you can use them to discuss how the products work. So let me give you an example. Here's Mira Lustrous Hair Oil. This is obviously one of my favorites. It actually is scientifically a really big achievement. This isn't just oil. This is a very specific blend of oils that actually adhere to hairs. If you look at this microscopic image of hair, you'll notice that there are little scales on each hair. Hairs aren't smooth. Those are called cuticular scales.
Beautiful.
And it's kind of like the trunk of a palm tree. As the hair grows, there's a kind of a ring, and it keeps building rings as it grows out from the follicle. So you get these scales across the surface of the hair. Mira is specially designed to be able to bind very, very tightly to a hair shaft. And that has to do with the way the molecules are charged in the oil blend. Okay? So now let me show you what that does in the real world. Here comes someone at our research institute who volunteered a hair. It wasn't me, I can't have any to spare. This is one of the women who work in the institute as a scientist, and this is their hair under a microscope. And I hope you can see that hair has sort of a rough surface. Those are those cuticular scales that I was talking about. Now if you take that hair and you apply a little bit of the oil and then rinse the oil off, this is what it looks like. You'll notice that it's totally smooth. It's covered all of those rough spots. And this is why the hair oil makes hair look shinier. It's why it allows you to comb or brush through it more easily. And it also is why your hair kind of is more manageable, because the hairs don't stick to themselves and get tangled up, because it smooths them. Okay? So this is the kind of imaging work that we do that helps tell our story. One more example. Product we launched this summer. Maximum acne treatment, maximum strength acne treatment. Yeah? You like it? It's a great product. It really is. Really, really fantastic product. As we were developing it, we worked with one of the leading skin imaging research centers in the world. They happen to be located outside of Philadelphia. And they allowed us to do studies like this, where we brought in volunteers who were clinically diagnosed with acne. And I realize this is sort of a difficult image to see, but this woman had acne all over her face, but there were 3 particularly bad lesions that I've circled here. These are really deep, nasty, sore acne lesions. That's a technical word for zit. After treating with our product for just 1 week, this is what she looked like. Notice that you can't find the marks that I circled previously. They're gone. Okay? That's just 1 week. Okay? So we knew that we were onto something that really had a significant anti-acne effect. And we use these kind of studies to then adjust the formula. We continue to monitor lots of human volunteers like this to see if the acne is truly clearing up, to see if it's drying their skin, to see if it's irritating. And based on the results that we get from these imaging studies, we adjust the formula until we get just what we want. And frankly, I think we nailed it. Now, let me show you why I think we nailed it. Do we know Amanda? Yeah. So Amanda sent me these photos, and God bless Amanda. She's a pretty brave lady to put these photos up on Facebook. And I do apologize for the quality of the image because it was lifted from Facebook. But Amanda started using our product, and that's sort of her at the top left of the photo before she started. And at the bottom right is where she ended up 1 month later. Yeah. This is the kind of result that, it really gets me. This is when I know we're really helping people. This is what I like to do. This is why I wake up every morning. It's great stuff. And I want to point out that this is something, not necessarily this, but this is the type of thing that all of you can do. There's no reason at all why you can't do your own kind of mini experiments and show how great our products are. Because that's the story that we need to tell. Okay? Let me show you a couple quick examples of some really easy things you can do. Thieves Household Cleaner. Let's talk about cleaning efficacy. This idea came to us when I caught one of my scientists eating in the lab, which is a no-no. They were eating a peanut butter marshmallow sandwich. So I said, hey, I wonder what happens if you put marshmallow on a piece of plastic and then see if we can clean it off. And that's exactly what you're looking at. This is marshmallow fluff, and it's smeared across a sheet of plastic. And on the left, what we did was we just took a paper towel, and we made it wet with water, and we wiped it through the marshmallow 1 time. On the right, we did the exact same thing, the same kind of paper towel, but we saturated it with Thieves cleaning solution and wiped it through. And look at the difference in the cleaning. This is the kind of stuff you can use to show how well our products work. Marshmallow, incidentally, is not easy to clean. It's a mix of gelatin and cooked sugar, and it's a sticky mess. And for those of you who don't have kids, you won't understand that until you have kids and you find it all over the back seat of your car. Now, let me show you just one more quick demonstration. This one I think is a little bit more dramatic for the Thieves Cleaner. Here we took a piece of glass and we drew a line on it with a glass marker, a magic marker. And it's pretty obvious what happened. We wiped it on the left with water and nothing happened. On the right, we wiped it with some Thieves Cleaner and it vanished. So this really, I think, demonstrates just how well these products clean. And you know what? These products are completely natural, and it's frankly our duty as kind of stewards of the earth to clean responsibly, right? And this is a way to do it. It's a way for you to show folks how well these things work, okay? Now, I'm sure this is something you think about all the time. I was laying awake last night just wondering, how do we establish expiry dates? Don't you all worry about that? Is anybody still awake? Yeah. Expiry dating is actually very important, right? You have to know when a product is kind of beyond its life cycle and when you don't want to use it. Now, oils don't tend to expire, so it's not so important for pure oils. But in other products we have, like vitamins, for example, it's very important to know when they expire. There is a very defined process that we use to determine expiry dating. Not all of our competitors do this, It is considered industry standard, however, so we adhere to very strict standards when we do it. Now, how do we do it? Well, we do something that we call accelerated stability testing. And this is where those pilot batches come in that I mentioned. We begin this testing with pilot batches, and we then continue it on full manufactured lots. But what we do is take finished product samples and put them in special chambers, cleverly called stability chambers. And this is what the chambers look like. If you've toured the lab at Spanish Fork, you may have been able to see these. They're not too visible through the glass, they're kind of around the corner. But we've invested over $1 million in these stability chambers for stability testing. The ones you're looking at in this photo are about the size of a refrigerator. And what we do is we put the product inside there, and then we can very, very carefully control the relative humidity and the temperature inside those chambers. Now, we also have larger chambers. This is one that's actually a walk-in chamber. You can see the door here, and the inside of the chamber looks like this, where we can put loads of products on racks. And we keep these products in these chambers for a long time, months and months and months. And what we do is, as I said, these are now at very stressful conditions, high temperature, high humidity. And then every month we go in and pull a sample of the product out and we test it thoroughly. We test it chemically to make sure that none of the chemicals have broken down, that everything is as it was when it was first put in there. And we also test it microbiologically to make sure there are no bacteria growing in that product. It's done according to a very strict process. And in fact, there's a formula that was developed years ago by a gentleman named Arrhenius. And that formula relates temperature and humidity to chemical degradation, chemical breakdown. And the way it happens to work out is that if a product is stable, if it doesn't degrade at all within 3 months in the accelerated stability chamber, we then know that that product is safe for a year at ambient conditions. So if we get it through 3 months of that testing, we can put a 1 year's expiry date on it. If we get it through 6 months of that testing, it's a 2-year expiry date. 9 months, 3-year expiry date. And that's just how it works out based on this formulation, this mathematical formula that was developed way back in 1893 by Arrhenius. This is called the Arrhenius Equation. And most chemists will tell you about the Arrhenius Equation if you ask them, so don't. Actually, Arrhenius won the Nobel Prize for this work. It's very, very important, and as you can imagine, millions and millions and millions of people depend on this work to ensure that they're ingesting safe products that haven't expired. The other reason I wanted to show you Arrhenius' photo is just to point out the fact that all great scientists have mustaches. That's important. Okay, so when we test our products, we need to test them against something. So I want to talk a little bit about standards. And I don't mean standard poodles, I mean chemical standards. Okay? These are chemicals or compounds or finished products that we already know are the best they can be. They're the ones that our products need to match. Okay? Now there's an entire international organization called ISO. It's the International Organization for Standardization, who does nothing but develop and test and maintain standards to which we can compare products. Okay? Now, ISO is made up, I believe, of 162 national standard institutes around the world. So it's really a lot of scientists coming together to do this. It's a lot of work. If you've never met anybody from ISO, you really should, because they are really exciting people. Incredibly boring work. It's very tedious, but I'm really glad they do it because it's very, very useful for us. Let me show you how it works. Let's say we want to look at peppermint. We can actually purchase an ISO standard of peppermint. Okay? That means you get a sample of peppermint, and you also get a booklet that looks like this. This is the cover of the book. It tells you all about the tests that were performed on the standard and how our tests should match those test results. okay? And if you open it, you'll see that there's all kinds of descriptions of, there's an appearance, and there's color, and there's odor, and there's density, and optical rotation, and refractive index, and they even give you the chromatographic data for that standard peppermint, okay? So this is a GCMS, it's provided by ISO for standard peppermint. And peppermint varies around the world, so they actually will provide standards for peppermint from France, and peppermints from North America, and peppermint from Asia, because they're all a little bit different. But you can see from this table that it shows you the actual peaks in the chromatogram that you should see if your peppermint is up to this standard. And it also labels what those peaks are, so you know the exact compounds that are in there. Now, this is all terrific, and it's a big help. But we're Young Living. We grow products and produce products that ISO's never seen. We're doing things that no one else has ever done before, so we're breaking new ground here. So we can't just buy standards for many of the things that we produce. So this is what we do. We actually have many of these mini distillation apparatus set up in our laboratory at Lehigh, in the research labs. And what we do is we actually obtain plants that we have genetically identified to be the correct plant, and we distill those, and we make oils right in the lab. So it never leaves our hands. And then we run it through all of our analytical tests, and we develop our own standards based on the plants that we've started with. This is an incredibly tedious product. Sometimes we have to distill the same plant 10 times before we can really get enough testing data to ensure that it's our standard material. But what we're doing now since I arrived is generating our own standards. I actually, when I got here, I said, let's start doing this. And our team is so good that since that time in 2016 when I asked them to start, they've generated over 200 new analytical standards, new plant materials, new oils. This is something that only Young Living has. No one else has this, no one else can do this, no one has access to these data. So when we say that we are assuring that your oil meets our standards, this is usually what we're talking about. Our standards, no one else's, only ours, and they're the best in the world. So the guys that do this asked me to throw up a few examples, and you can read all of the different plants on these slides. This one goes from radiata to blue yarrow, and then we've done work on wintergreen right down to white camphor wood for sacred frankincense. We've also done a lot of testing on our own lavender because that varies depending on where it's harvested. Nutmeg, spearmint, myrrh, down to Kunzia, which is the newest single that we launched this summer. I love Kunzia.
Me too.
Who's used Kunzia? It's my new favorite. My new favorite. This summer I spoke about it a little bit. It's really, really wonderful to diffuse. And let me just tell you a little bit about it. It comes from this plant. This is Kunzia ambigua. Kunzia ambigua is a flowering shrub that lives in a very, very remote part of the world. Lives way, oh, somebody missed my circle. Pretend that's shifted over to the right. Tasmania. We get it right out of the middle of the ocean, right tonight. It comes from Tasmania, which is that small teardrop-shaped island just to the south of Australia. And the reason I'm showing you that on the map, or at least trying to, is to demonstrate just how remote Tasmania is. And you know, remote generally means pure, right? This is a very wild, rugged place. And it's an absolutely beautiful place. Does the video not play, folks? Oh, there we go. Okay.
Aww.
This is Flinders Island, which is actually an island off the northeast coast of Tasmania, where we harvest the Kunzia ambigua. And here you can see it growing in the wild. We've actually begun to try to plant Kunzea so that we have a sustainable source of it rather than harvesting the wild material. And this is actually the Kunzea planting here that you can see. It's an absolutely beautiful plant in an absolutely beautiful part of the world. Now, Tasmania is known for all kinds of interesting animals. There's a little Tasmanian devil. It's what we used to call my youngest daughter when she was young. For good reason. But I really want to talk about this animal. Actually, I don't even want to talk about this animal. What I want to talk about is what's holding that animal back. Look at the fence in front of the steer. Okay? That fence is made out of barbed wire. Now, this is a really intriguing story that we heard from the folks in Tasmania about Kunzea. Barbed wire is very cheap steel. It tends to rust very easily. It oxidizes. That's what rust is. It's oxidizing metal. It happens that a rancher noticed that when the barbed wire happened to be strung through Kunzea bushes, it looked more like this. No rust, no oxidation, right? What's the implication there? Kunzea is loaded with antioxidants. That's about as far as I can go compliantly.
I use it on my face every day.
But it was a really interesting story and a great demonstration of what the Kunzea bush itself is doing. Now just imagine what happens if you concentrate all that into an oil. Now Kunzea was traditionally used by the Aborigines to soothe irritated skin, to help with muscle tightness. But the other thing that I think is really a fun fact is that when the Aborigines were out hunting and it got dark and they wanted to sleep for the night, they would find a Kunzea bush and they'd crawl under it. And they said that that was because it repelled insects, in particular ticks. So in Tasmania and in Australia, the colloquial name for Kunzea ambigua is tick bush. Kind of cool. Today, the modern Aborigines use it as aromatherapy for relaxation, it calms, and it actually is very good for your skin. And here's a compliant claim we can make. It helps with the appearances of blemishes. It actually helps to fade blemishes on the skin. So I really think of Kunzea as kind of being nature's little miracle. Think about a single oil from a single plant that's high in alpha-pinene, which we also get from pine oil. It's high in 1,8 cineol, which we call eucalyptol. It's the predominant compound in eucalyptus oil. It's also incredibly high in something called veritafluoral. There will be a quiz later, by the way, what to pronounce all these. Veritafluoral is one of the key components of peppermint and sacred frankincense. It's also very high in bicyclodermacrene, which is in oregano and hyssop. And finally, it's very high in alpha-terpineol. And that's actually a fragrance that's highly prized by the perfume industry because it's part of the things that make lilac smell like lilac. So, if you want a single oil from a single plant that has all of the tremendous compounds that we get from pine oil, from eucalyptus oil, from sacred frankincense, from peppermint, from hyssop, and from oregano, all with a hint of lilac, this is your oil. It's really good. If you haven't tried it, try it. This is truly nature's miracle. I like to kind of end on a miracle, so I think I'm going to call it a wrap at that point. But what I do want to say to all of you is you're always welcome to come see the research labs and the product development facilities at the D. Gary Young Institute. So anytime you're in town, give us a call. We'd love to show you around. We have a lot of scientists who love to talk about what they do and how they do it. And they love to hear your questions and your ideas. And with that, I will say thank you very much.